I'm Sanket Mishra and I'm here to present our contribution on a modified version of convolutional neural networks, that is tree-based convolutional neural networks, for detecting network intrusions. We would like to thank TCS R&D for funding this research through TCS PhD Fellowship. We start with a brief introduction in the area of intrusion detection and the importance of intrusion detection systems in preventing such attacks. Further, we present the overall design of the proposed framework and discuss the various phases involved in it. We first elaborate on the feature selection approaches undertaken in this work to identify the suitable features. The next section introduces tree nets, that is the proposed hierarchical tree-based neural networks, and then we depict the performance of this approach against standard approaches or the state of the approaches on the basis of standard evaluation metrics. Finally, we summarize the major findings in this work in conclusion. Attacks or intrusions in a network infrastructure compromises it. The objective of intrusion detection systems is to learn attack patterns and to prevent it, so that there is no disruption in the services. In this work, we propose a tree-based neural network called as tree nets to identify such network intrusions. The model employs incremental learning to segregate different classes of attacks. The framework is broadly divided into three phases. We select the most suitable features using binary gray wolf optimization approach, which helps in improving the performance of the proposed approach by reducing the overall dimensions of data. We then employ tree nets that represent a hierarchy of classifiers and in which the root node classifies the data point into one of its child node, which are also in turn a classifier. We validate the performance of the proposed approach on the basis of standard classification evaluation metrics, that is accuracy, precision, recall, and F-measure, and conduct a extensive analysis using different ablation models to compare the performance. Feature selection. This work, we use gray wolf optimization, which is a nature-inspired algorithm that depicts the social behavior of wolves. In this work, the feature selection procedure is considered as a binary optimization problem to identify optimal set of features. The fitness function helps to fetch fitter individuals from candidate solutions as decided by the error rate. Our model begins as a single classifier node that classifies three class levels. Each non-leaf node is a classifier model, while each leaf node is the output. In each iteration, 5 classes are added and the growth is controlled by using alpha and beta that decide where to group the new classes. We have used tree ANNs and multiple CNN variants in this model as ablation models, and the models are having different hyperparameters. The hyperparameter subspace is depicted in this slide, and we have tried to find the optimal set of hyperparameter using hyperopts Bayesian optimizers. The ideal hyperparameters obtained thereof has been also attached in this slide. The tree begins as a single classifier that can classify 3 classes, and in each iteration, because of the incremental learning characteristic, 5 new classes are added. These classes, the new classes, can be added as a child or merged with 2 nodes or added as a subchild subsequently. This slide depicts the performance of our approach on the basis of standard evaluation metrics. As it can be seen, the proposed approach, that is tree CNN reduced with binary gray wolf optimization and without binary gray wolf optimization, performs better than other approaches in terms of accuracy. It is also performing subsequently better and ranked second in terms of precision. However, we have noticed a drop in the performance on the basis of recall and F-score. But even though there is a drop in the performance of recall, in the F-score, in terms of F-score, it is still ranked second highest. As it can be seen, TreeNet, we have used different variants of TreeNets. The tree CNN basic is the original tree CNN proposed, while the tree CNN reduced is the modified version incorporating early stopping, model checkpoints, and weighted loss functions. We can see that tree CNN reduced BGWO performs better than the other approaches. In this work, we presented an incremental learning approach, tree nets, to identify intrusions in a network. We achieved a competitive accuracy of 82.17% and 66.37% on KDD Test Plus and KDD Test 21 respectively, which is at par with state-of-the-art approaches. When we include binary Grey-Wolf optimization based feature selection, it leads to 0.8 to 1.2% improvement in performance across the evaluation metrics. This also opens a scope to try with different swarm intelligence based feature selection approaches for better performance. A sensitivity analysis and ablation study conducted in this work also verifies the impact of various parameters on overall performance. Thank you.